Hi guys, welcome to section 3 of this interesting course. So for section 3, we're going to be analyzing Autogon Data Analytics, Visualization, and Auto-Generate Dataset functionality. And yes, in line with analyzing all of this, here is the table of content from data preprocessing to types of data and data sources. We're going to dive deep into data preprocessing because data preprocessing is a very important phase of building interesting, accurate AI models. So, introduction to data analytics and visualization. Understanding data analytics process very crucial for effectively extracting insight and making informed decisions from your data. Very important. And yes, data analytics process involves several key steps. So on the right, we can see this image. One, define why you need data analysis. Two, begin collecting data from sources. Three, clean through unnecessary data. Four, begin analyzing the data. Five, interpret results and apply them. Yes, data analytics is actually very important. Importance of data visualization in decision making. Data visualization plays a crucial role in decision making across various industries and fields. It goes beyond presenting data in a visually appealing manner. It's a powerful tool for conveying complex information, identifying patterns, and gaining insights that can drive effective decisions. So prior to this time, on section 2, I showed us how Autogon auto-visualize data, generated some interesting charts and gave us super interesting insight about our data sets. Okay, so benefits of data visualization tools. So we can see some of it. We take number 2, increases the speed of decision making. And this is what individuals and businesses need to have as an ample advantage. At every point in time, you want to be making fast, precise, and accurate decisions every single second. Yes, so it promotes storytelling and conveys the right message to the audience. Very important. Identifies errors and inaccuracies in data quickly, and many other benefits of data visualization. So types of data and data sources. So data comes in various types, and it's important to understand these types to effectively work with and analyze the information you're dealing with. So in time past, we solved a classification problem, and we also solved a regression problem and an object detection problem. Yes. But there's something very key between the classification problem and regression problem. So the dependent variable were of either categorical type or a numeric type. So categorical type, yes, you can see feature or variable, categorical or numerical. So when it's categorical, can take one of a limited and usually fixed number of possible values. Sometimes you can find a numerical value, but it's actually a categorical variable. In the terms of, let's say, we are trying to identify different behaviors of students in line with their class. So let's say the class is actually 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 classes in total. That's actually a categorical variable, even though it's actually numeric numbers, but it's categorical. Yes, because the 1, 2, 3 all represent classes. And not real numbers, and not an ordinary numeric number, but it's a categorical number. So yes, you can see it can take one of the limited or usually fixed number of possible values, like the class. Example: blood type of a person, ethnicity, gender, true or false. Numerical. A numerical variable is a data variable that takes on any value within a finite or infinite interval. So it's very important that you understand this caveat around the definition. Yes, this one says can take on one of a limited and usually fixed number of possible values, and this is saying A numeric variable is a data variable that takes on any value within a finite or infinite interval. So example, height, weight, age, number of movies, salaries, childbirths, every month, every day. Those are different numeric variables. So under categorical, then there's nominal and there's ordinal. So it's important you understand this. But you don't need to stress yourself at this lower level. These two at this higher level is fine in building interesting models. You don't need to stress yourself about this lower level, but you begin to stress yourself at this lower level when you are trying to put up your data together, analyze properly, segment, clean up properly if you're manually doing all of those processes. So nominal variables describe categories/groups that do not have a specific order to them. Example, blood type, ethnicity, gender, or color of car. But if you look at ordinal, I have two or more categories that can be ordered or ranked. Response data that ranges from strongly disagree to strongly agree. Yes, so it's just a very slight difference, but both categorical variables. Like I said, don't stress yourself about this lower region. Just stress yourself about the categorical and numerical. Yes, beautiful. So I placed two data sets here, categorical data sets and numeric data sets. Let's quickly visualize these data sets. So this happens to be a categorical data set. So we can see the CSV, and the last column here has to do with deposits. So this happens to be a bank data set, and after engaging different customers, so we can see, oh, did this one deposit? Yes. Some of them did not deposit. So a lot of them deposited. We can see a lot of yes. Oh, okay, we can see a lot of no. So yeah, so this is a categorical variable. Yes, no, categorical variable. True, false, categorical variable. 1, 0, categorical variable. Then I also placed a numerical variable here. So if we visualize it, so we can see TV, radio, newspaper, and sales. So we can see, this was a company that advertised using each of these channels, each of this medium, and they were recording how much spent and total amount of sales they got. So yes, I can see 230.2 hours spent on TV, 37.8 on radio, 69.2 on newspaper, and 22.1 was the sales. That's the return on investment. And you can see the return on investment varies. Yes, it's a continuous value. It's not like, you can see the definition here. A number variable is a data variable that takes on any value within a finite or infinite interval. Yes, and see these are continuous values. 10.6, 8.9, 9.2. They are all just different numbers. There's nothing keeping them like in, so like usually fixed number or number of possible values. So yes, they're out of that boundary region. So yeah, so this is a numerical data. That's for the sales. And if we're wanting to even solve a problem where TV, radio, newspaper, we're trying to understand the relationship as regards the sales, yes, we'll be building a regression model to understand the relationship between each of these independent variables in relation to the dependent variable. Same as if we're trying to build a machine learning model that understands all of these independent variables as regards this deposit, yes or no, we will be using a classification algorithm. So data sources. So data sources are the origins of information used in machine learning and other analytical processes. So there are different types of data sources. different sources where you can want to bring in data from. You can have this thing in your CSV format, the output of your Excel sheets. You can export your Excel sheets into different formats. It can coming from Google Sheets. It can coming from a REST API, either a SOAP or a JSON. Data mapping. You can be coming from your database. Either you're sending it from SQL Server, you're connecting your SQL Server to Autogon, or you're connecting your MySQL, Oracle, Postgres. And different other types of databases today you can connect to Autogon AI. Yes, so the goal is you learning how to connect your data source properly. So data pre-processing and cleaning. Okay. Data pre-processing is a critical step in data analysis process that involves cleaning, transforming, and organizing raw data into a format suitable for analysis. Yes. So most of the time, you will have data sets, and the is either you want to tweak the structure, or it's a dirty data set, or it has a couple of missing columns, or numeric and categorical data merged together, or they're just several things. So your data sometimes can be dirty. Data pre-processing phase is the phase where you take your time to properly pre-process your data set into a very organized manner that the machine learning algorithm can make the best insights out of your data set. So data pre-processing, there are different sections under data processing. There's data cleaning, data transformation, and data reduction. Data cleaning, so there are a couple of algorithms you use in your data cleaning for missing data, for noisy data. Under data transformation, yes, normalization, attribute selection, and all of these other guys. Data reduction, numericity reduction, dimensionality reduction. These are different reduction techniques that you can do. So you bring in dimensionality reduction when you are trying to further remove noise and some unnecessary columns. Yes, and very important in data processing. Okay, so very quickly we're going to jump into studio environment, and yes, we're going to be working on this particular data set here. Copy link address, and we would open studio environments. Firstly, country, age, salary, purchased. So the first thing we're going to do is to create this data set. So we'll call it data pre-processing data set. So I'll just paste the URL, in which if you've downloaded it, you can always upload. I'll just paste the URL, and yes, and I'll just paste same thing here and create the data set. Okay, so then we'll come create a project dedicated for this, and we'll call it section 3 and data pre-processing, and I can paste equal item here, and I create my project. Okay, beautiful. So we're not going to be using Studio Wizard. Studio Wizard automatically does the data pre-processing for you and builds the model. We're going to be using Studio environment. However, there are some very complex data sets that I'll urge you to pre-process on Studio before coming to do same on Studio Wizard, especially when you have stuff like very complex, and so when you are mixing here, you are mixing different different attributes together, and those attributes are meant to be separated so the model can understand the relationship between each of the constituent attributes. So so that's one condition where I'll suggest you don't use Studio Wizard. if you want to see the correlation between each of those constituents, you just go do pre-processing on Studio, and you can export it and bring it back to Studio Wizard. But yes, in all cases, you can use Studio to build whatever machine learning, deep learning project. So we'll quickly launch Studio. And these data sets that we're going to be working on now, we can build this model also using Studio Wizard. So when we're done pre-processing on Studio, we'll get our result out of Studio. We'll go do the same thing using Studio Wizard. Okay. So we'll close these previous items that we've worked on. And the first function block that we need to pick out is called the data input under data pre-processing. So this data input block, this is where we pass in our data source. So if it's a database, select your database, enter the database URL. If it's a MySQL, then begin to enter the details. If you see the Google Drive or a CSV. So here we're working with a CSV or a JSON or a zip. So we're working with a CSV. I just select CSV and paste the CSV URL. I thought I copied it. Okay, 1 second. Copy and paste our URL. Then we'll run this block. You can see data input successful. Now, a quick run through of the Studio environment. This f of x, these are your functions. So these functions are available for you: data processing functions, machine learning functions, deep learning functions, automated machine learning, automated deep learning functions. This is your Canva area. You can see run all blocks. If you have multiple blocks, you can just click run all. Yes, so when you drag in a particular property and you click on it, this shows you the function property. And yes, you could always chat to the bot even as you are building stuff to guide you on what and what to pass. And this is the variable section. Like we ran the data input block, so we are going to see the variable coming from the data input block. And you can see when we double click on this data set, we can see the data set we just imported. 10 rows, 4 columns. Beautiful. Now, this is the data set block, or the data set in your account. So you can easily pick up a data set like this. We would have just clicked on this and copied the data set and come put it here instead of going through opening a new tab and doing what we did. And this happens to be models and weights. So for this particular project, we've not built any model and we don't have any predefined weights. Once we get any predefined weights and we build our models, I'll come show you here. You see all models and you can copy the models. Okay, and this happens to be your error log. So as you're building and there's an error, you will see the error pasted here. For instance, we'll send this same file. Let's copy this. I'll send this same file, and then we just omitted 2 characters. Good. And you can see forbidden. And if there's a logical error with what you're doing, you also see the error here. So let's import this back, and successful, and the error is out. Good. And there's the pipeline prediction error. So you can also inference your model on Studio. It's a very holistic environment, powerful IDE, and if you inference your model, you can see the entire logs of the inferencing, what happened across the pipeline before your model returned an output. And switcher, yes, I'm going to come back to switcher, because at switcher, this is where you are able to create pipelines after you've built models. I'll show us how to create pipelines. And so that's all about the Studio environment, and you can always search for functions. XGBoost, yes. You can only search for functions, and when you search for functions, you can always drag those functions. Dragging is as simple as you just hold on it and drag it to the Canva. Very beautiful platform, highly customizable. You can build very simple to complex models on studio environment. Yes, custom models, tune your hyperparameter yourself manually to achieve very crazy accuracies. Okay, so back to our project. So if we click on variables and we double click on dataset, we can see the variable outputs of the datasets that we imported. Note that we can see there's some things I need to explain here. So the goal here is to build a model, a machine learning model, based off of understanding each of these independent variable to predict the dependent variable purchased. So this is the data set from a business, and the customers that purchased, these are different countries of the customers, the age of those customers, and the salary of what some of those customers are earning, monthly salary or annual salary, and did they end up purchasing probably a car or whatever. And this one no, this one yes, this no, this yes. But if you notice, probably the survey this business tried in getting each of this information, this particular customer from Germany refused to disclose his salary. This other customer refused to disclose his age. This customer from Spain, but however, his salary was disclosed. Yeah, so and because of each of these blanks, these are called missing data. So before we proceed to build our machine learning model, we want to clean up all missing data. This is a missing data, this is a missing data. And there are several ways we can handle missing data. Is either we go through using the mean, using the mode, or using median of this column. Yes, but in most cases, you can use the mean. So you can always use the mean, and I'll show you how to calculate and compute all of these items. Okay, so we're going to go ahead with preprocessing this particular data set. So we will start first by handling these missing values. Yes, once we're done with the missing values, then we can go ahead to separate the independent variables from the dependent variables. Then step 3, we can then come down to this country and preprocess the country into an acceptable format. You can see it's in text format, and when you're building machine learning models, it requires it to be in a numeric format. Good. So we're going to start with step 1, which is handling missing data. We'll come under data preprocessing, and we'll drag in missing data and connect data inputs to missing data. Then when you click on the missing data, it tells you what strategy do you want to make use of. We're going to make use of the mean. You can use the median, or you can drop off. So depending on your understanding about your data set. Yes, so some data sets you want to use most frequent, some data sets you want to drop it out, especially for a data set where the account balance, let's say you are doing a transaction monitoring, and the amount that is moving from destination A to destination B is null, is missing. That particular column is actually a very important one, so you can't go ahead to say for that particular column, I want to use the average, that's the mean, the average of the items on the column. So you don't want to go through that. So in that case, you want to drop off that particular record. Good. So for this case, we're going to use the mean. Now, notice something about the boundaries. Yes. So 2 ways you can specify boundaries on Autogon AI. Now, if we look at this data set, from this, we can see here that country 1 happens to be the first column, 0. age happens to be the second column, 1. Salary happens to be the third column, which is 2. Yes, notice 0, 1, 2, and 3. Very important. Now, if I'm wanting to reference age, I will specify 1. If I'm wanting to reference salary, I'll specify 2. Okay, so looking at the variable, yes, if you're specifying country, you're specifying 0. That's the index of this column. If you're specifying age, you're specifying 1, salary 2, and purchased 3. So we're wanting to handle missing value for column 1 and column 2. Exactly. So and yes, we're going to be entering column 1, comma 2. And if we run this, we give this some seconds to run. Good, successful. And when we open this and open the data set, we can see beautiful 38.77777778 happens to be the mean of this particular column, and 63,7777.7777 happens to be the mean value of items in this column. Beautiful. Now, notice the way I specified boundaries. Notice the way I specified boundaries. Yes, there are 2 ways you can slice data on Autogon AI, that you can select data or sort data on Autogon AI. You can go through slicing, and you can go through specifying via column IDs. Good. So the next preprocessing step we're going to take, we are going to go ahead and separate the independent variable from the dependent variable. You can see Autogon platform has already auto-assigned the respective indexes. So we're going to separate index 0, 1, 2 from index 3. So, and the way to do that is to come back to our data preprocessing and look for feature sampling, and we'll drag feature sampling and connect feature sampling to missing datasets. Notice I did not connect feature sampling to data input. So I connected feature sampling to missing dataset. Why? Because I am trying to leverage the datasets I've already cleaned. So our dataset has moved from this layer 1 to this other layer. So I'm trying to leverage the dataset I've already cleaned from this particular layer, and which that dataset is now available at this particular layer. As simple as that. So if you click on feature sampling, now we are asked to specify the boundaries again. Soon I'll show you how to use slicing. Slicing is a very easy and simple form of selecting or sorting datasets. So but for now, I'll go ahead and pick that particular dataset via the column IDs. So I'll pick 0, 1, 2 for the independent variable, and for the dependent variable, I keep it as 3. So 0, 1, 2 is going to be the X value, and 3 is going to be the Y value. So if I select feature sampling and I enter 0, 1, 2 being the X boundary, the independent variable, and the dependent variable, I'll specify 3. So if I run this, we'll give this some seconds, and you can see the output has just been updated. So if I click on the X value, we can see 0, 1, 2. Beautiful. And if we click on the Y value, which is the dependent variable, we can see the dependent variable results. Beautiful. Okay, we're making progress. Yes, so all of these processes are processes for pre-processing your datasets. Beautiful. Okay, so the next step before we go ahead to want to build our model. Okay, so we would go ahead to bring in the algorithm that is going to encode this particular column. And yes, there are multiple algorithms that we can use for encoding, but to encode this particular column, we are going to be using the one-hot encoding, and I'm going to explain why. So now, if you notice, France, Spain, Germany, Spain, Germany, France. Now, you use label encoding when you are dealing with two categories. So meaning we'll be breaking them into 1, 0, 1, 0, 1, 0. And you use one-hot encoding when you're dealing with more than one categories here. Good. Then aside the one-hot encoding, let's go ahead and drag the encoding, data encoding. Good. We'll connect the data encoding to our feature sampling. Good, beautiful. So we select, so you can see there's the binary encoding, there's target encoding, there's one-hot encoding, extract number, string to hash encoding, label encoding. These are different algorithms for encoding. You can read the documentation to understand. But for this case now, we'll use one-hot encoding. The two popular items are label encoding or one-hot encoding. And I said why we are using one-hot encoding, because that particular category is not binary. It's not a binary category. If it's a binary category, we're going to use the label encoding. So we select one-hot encoding. Beautiful. So it requires what variable. Now we will specify x variable being the independent variable, and remainder select pass through index. So let's go check out the index. Index what? Index 0. Beautiful. If you got that right. And index 0. Now load name, save name. Yes, so this function, this data preprocessing function, it's a function that generates a weight. So when you are building models and you use a function like this, yes, you can save the weights so you can use it for a later time. So I'm going to call this data encoding, and country. So you can use any name, and we'll go ahead to run this data encoding block. We'll give it some seconds to run, and it goes ahead to encode every single thing on the dataset for column 0. And when it's done, it saves the weight of that particular encoding. When we get to pipeline, I will show you the benefits of saving weights. So let's give this some seconds to run. Good, it's done running. So let's go ahead and visualize our data set. So the x value, which is the independent variable, and beautiful, it has been encoded. So you can see this is most likely Germany, Spain. This is Germany, Spain. I think this is, I don't know. Yeah, there are 3 countries basically. So now we've encoded the country column, which is beautiful. And this is for age, and this is salary. And congratulations, your data set is ready for building models. So just one final step before we celebrate fully. We need to bring in feature scaling. Now you have your data set in this format. If you notice, column 1, column 2, column 0, 1, 2, their number, the values are distributed between 0s and 1, and 3, 4 are not otherwise. So we'll need to scale this data set so that the numbers can be evenly distributed. Yes, and there are 2 types of scaling we can use. We can use the normal scaling, or we use the standard scaler. But before we go ahead to scale it, there's a step that's actually very important. We need to split the data set into train and test set. Yes, and to split this data set into train and test set, and I'll tell you why. So when we're building the machine learning model, it learns from the train data, and when it is done, it carries out validation on the test data. Good. So once we've done splitting it into train and test set, then we can go ahead to apply our feature scaling. Now, you don't apply feature scaling, then split train and test, so as to the standard deviation weight that you've used in the scaling will not leak out to the test set. So now we are going to split this data set. So we'll come to data processing and look for data splitting. And we can also bring in, after data splitting, we're going to bring in feature scaling. Beautiful. So we'll connect data splitting to data encoding. Zoom this so you can see. And we'll connect feature scaling to data splitting. So now for data splitting, yes, it's a standard value to give to differentiate the train set from the test set is assigning 20% to the test set and 80% to the train set. So yes, so we can use that same value here. So we assign 0.2 meaning 20% goes to the test set. And yes, we can keep this random state as 0, and we run data splitting. So I will give this some seconds to run. Okay, we have our value. My network is a little slow. We have our value already. Our data splitting done. Now, if you notice something, so there's the X value, Y value, X train, Y train, X test, Y test. Now, the X train and the Y train happens to be for the train set, what our model is going to learn from. And the X test and the Y test is what our model is going to validate on to determine its accuracy. Exactly. So now, we used 80% for the train set and 20% for the test set. So if I open the X value, the total data set here is about 10. Yes, you can see 10 rows, 5 columns. But if I go to open the X train, you can see 8 rows, 5 columns. And that's because we've assigned 80% of our data set to the train and 20% to the test. So if I go open X test, can you see 20% have been assigned to the test? Beautiful. So we're making progress. Now, this is data splitting, and it's a very important methodology, or a very important route to go through when you're building your model. Yes. So your model learns from the train set, so it can be validated on the test set. Now, feature scaling, we also dragged feature scaling. So we'll need to scale the train. We'll select a scalar. We're going to be using, we use min max scalar. Now, why min max scalar? Let's look at the X train. Yes, I would love to scale every single thing in the light of ones and zeros. Yes, so you can go through either the min max scalar or the standard, scalar. Either of it works for this data set. Now, we would carry out our scaling on the train and fit it on the test. Yes, we'll carry out our training on this train and fit it on the test. So X train and X tests. Exactly. Good. So select standard scalar, then boundaries to scale. Again, we're asked to provide boundaries. Now, if you look at the X string, we want to scale basically column 3 and column 4. So I'll just click on this and enter 3, 4. Then save width. The name to save the width, I just type feature scaling underscore width. Any name works. And we'll run this. Great. So if we look at our X string, what did you notice? Column 3 and column 4 has been scaled. And because we selected standard scalar scales between 1 and -3. And that's why we're having this. If we use min-max scalar on the same boundary, we can run this again. We'll give this some seconds to update. Great. So if we double click on the X string, what did you notice? You can see it has been scaled between 0 and 1. Beautiful. So it's either you use the standard scalar or you use the min-max scalar. You can go read more on scaling and understand clearly when you need to use which exactly. So now we can see the X string. Let's go look at the X test. And you can see, so the scaling fits on the train and transforms the test. I just have a slow network. Good. Yes, so the X column 3 and column 4 has been transformed, which is beautiful. So like this now, our model is ready to be built. And to build our model here is to go ahead and drag in the classification algorithm. Why classification algorithm? If you look at the Y test, it's actually a classification problem. Yes or no. Exactly. So we can come drag in a classification algorithm. We can use random forest classification. And we connect it to feature scaling. And yes, one more thing we need to drag. Let's drag in random forest classification predicts and random forest classification metrics. Good. So we connected random forest classification to feature scaling, and we'll connect random forest classification. Let me just structure this format. Okay. Connect the predict to the random forest calculation classification, and the metrics to the predict. Now, here you enter the name of the model you are trying to build. So I can call it random forest classification, RFC. Works. Criterion, that's the hyperparameter. I'm going to explain by the time we go deeper into each of these classification algorithms. I can leave the default there as Genie, and we run this. So we run this, and what is simply happening is a machine learning algorithm, classification machine learning algorithm is being built on the trained data sets. Exactly. So we'll give this some seconds to run. And once it's done running, we would see the model, width of the model will appear here. So let's give this some seconds to run. Okay, so our data set is done running. Our machine learning algorithm is done running. Okay, our machine learning algorithm is done running. You can see successful. And if we click on the model, now we can see the width of the model. Beautiful. Okay, so the next thing we're going to do, hence our model has been built, we would specify the name of the model here, RFC under predict. We'll specify the name of the model here, and yes, we'll leave this at default. We're trying to predict. What we're simply doing here is, so you can specify any test data set. What we're simply doing here is to predict the X tests. So now, if you look at this, we have the X test and the Y test. So we're trying to predict the X test to get the Y test, yes or no. So we'll go ahead to run the prediction. So when you don't specify anything here, it uses the default X test. So we're predicting the X test to get the Y test. So good, that prediction is done. So if you notice, we'll now have a Y pred. So, and if you look at your Y test, no, yes. So let's look at the Y pred. And the Y pred is yes, yes. So the model got one item accurate and got one item inaccurate. And if we go ahead to check the metric of this model, we simply specify the name and we run the metric to confirm the accuracy. Let's give this some seconds. And the accuracy happens to be 0.5. And I'll tell you why. Yes, we have this very low accuracy because our data set is very small. So the model does not have enough trained data and enough test data. It only has two test data, two different records as test data, and it failed one, it got one, so accuracy 0.5. So a way to greatly improve the accuracy up to 100%, 0.5 means a 50%. A way to improve the accuracy is to bring in much more data sets. So I've just showed you how to go through pre-processing your data set into building a super interesting machine learning model. So we started from the data inputs. We selected CSV because our data is in CSV format, and we specified the CSV. And when we viewed our data set, we discovered some things that needed to be cleaned up. So we discovered the age, we discovered the salary, that there was missing value in the age, there was also missing value in the salary. We also discovered that the country column needed to be encoded, and we applied the one-hot data encoding mechanism to the country column. Then we also splitted the data set. We separated the independent variable from the dependent variable, and the dependent variable purchased. I know some of you will be wondering and say, why did we not encode the purchase? Because it's the dependent variable, it's not necessary. Yes, it's not necessary. And again, depending on the algorithm that you're wanting to use, there's some algorithms that are going to flag it. Yes, there's some algorithms that are going to flag it. So depending on the algorithm that you're wanting to use. So it's not necessary in this case. But there are some cases where you also need to encode the purchased, which is the data encoding, which is the dependent variable. And the encoding metrics we're going to use for it is the label encoding. So no becomes 0, yes, 1, 0, 0, 1, yes, we encode it. And yes, as simple as that. So if you encode it and there's a prediction, what you'll be seeing as a prediction is 1 and 1, being yes, yes, 1, 1, instead of yes, yes. As simple as that. I'll close this. Yes, you see 1, 1. Yes, I'll close this. Okay. So this is how easy it is to build a machine learning algorithm using the Studio environment. And I'll show you how to build some more interesting and more complex machine learning algorithm. So after handling missing data, we handled feature sampling, and then we separated items. Then we handled data encoding, and then we encoded that index 0, and we handled data splitting and feature scaling. Now, two more things I'm going to show you. I'm going to show you, so note that for boundaries, we were entering column IDs. Now, this is not scalable when you have a data set with so many columns. So I'm going to show you, the first thing I'm going to show you is slicing, understanding how to slice. That's number one. Then the second thing I'm going to show you is using Autogon Auto Data Preprocessing function. That's number two. And the number three, the third item I'm going to show you is we've built the same model using Studio environment, very small data set. You can do this using the Studio Wizard environment. So let's quickly do that using the Studio Wizard environment. So using the Studio Wizard environment, section 3, data preprocessing, and if we click on view details and we select Studio Wizard environment, we can select data processing dataset, and you see how Studio Wizard auto preprocesses the dataset. So you can see the mean has been generated automatically and the standard deviation as well. And we can see number of missing values on the age 1, number of missing values on the salary 1. So if we click next and it tells us what problem, we select classification, and what are we trying to predict? We're trying to predict purchased, and we go ahead to specify the model name. So we can call it purchased underscore P, meaning prediction. And we'll click on train. Very small data set. Don't do this. Don't do this. Yes, so if you want to build highly accurate machine learning models, give the algorithms more data sets. Yes, don't do this. But just for test purpose, I'm wanting to show us the difference. Okay, we have an accuracy of 0.3. Yes, I'm trying to show us the difference between going through the Studio route and going through the Studio Wizard route. So this particular Studio Wizard auto preprocesses the dataset and looks and runs through all machine learning algorithms. And yes, so you can see we have an accuracy here of 0.3. Don't do this. Okay, so and on Studio we had an accuracy of 0.5. I will not really guarantee that 0.5 is actually a very small data set. Yes, actually a very small data set. But okay, so the next thing I'm also going to show us is boundaries. how to use slicing to sort for boundaries instead of specifying column index. So let's fall back to our lecture. Okay, view dataset, counting missing values, handling missing values, good, slicing. Now observe image 1 here. So item 1 0, item 2 1, 2 3 4 5 6, and not 1 2 3. Counting starts from 0. Take note. And now for every data set, the last item is always -1. For every data set, the last item is always -1. So if you specify -1, you are referring to the last item on the column. That's the last column. It's always -1. Now you can see some small drills here. Word 0:7 will give amazing. 0:7, you count 0 1 2 3 4 5 6. Now notice something. 7 was specified, but there's no 7, and that's because the upper bound has been taken out. The letter starting from 0 going up to 7 minus 1, that's 6 from indices, so 0 to 6 both inclusive, exactly. So the upper bound is taken out. So when you see 0:7, you are dishing out the upper bound. Now 0:3, 0 1 2 3. But because of the upper bound dished out, we are referring to 0 1 2. Now 2:5, 2 3 4, as in -7:-3. Now look at the count. -7, -6, -5, -4. Did you see the count? So -7 to -3 is equivalent to 0 to 4. But this has been taken out the upper bound. Now -5 to -1, -5, -4, -3, -2, AZIN. Understand slicing. With slicing, you can select every item. So if I want to select every item here on the rows, so I'm going to explain good. I've just showed you this. Let's get into this other place. So I can explain rows and column properly. Now see this data set: 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 and 16, and this is a 4x4 matrix. Very simple. We're not going to any complex math. Now array 1, column 1, 2, 4, 1, 2, 4. Can you see the result? 7, 8. And let me explain why. Firstly, rows and column. Row 0 is this. Row 1 is this. Then this is the colon, and this column says 2:4. So this is specifying the rows, and this is specifying the column, and this column says 2:4. So now 2 is what? 0, 1, 2. Colon 4, meaning we're doing 2, 3, and 4, but there's no 4. So you disbound that upper guy and you're talking about 2 and 3. But for row 1, that's why we have 7 and 8. Let me explain again. When you are sorting a matrix, this is a 2D matrix, 4x4 matrix, 4 rows, 4 columns. And when you enter a sliced value like this, because most of the time you are dealing with 2D matrix on Autogon environment. So when you're asked to slice, now the first item here represents the row, and the second item here represents the column. Row 1. Don't forget, counting starts from 0. So this is 0, this is 1, this is 2, this is 3. And this for rows. So row 1. This is row 1. Then column, on the column side, we're referring to 2:4. And on the column side for row 1, if you count, this is 0, this is 1, and this is 2. And don't forget, the upper bound is going to be dismissed. So 4 is going to be dismissed. So we're referring to 2, 0, 1, 2, and 3. Clear? Okay, so looking at this order matrix. So this order matrix says the row is column and the column is 1. There's colon and there's column. Rows and column. But this is a colon. Yes. So now when you see the colon, it means standing alone, it means everything. So on the row side, we're saying everything. So meaning everything, all the rows, all the rows, all the rows, all the rows. And on the column side, we are saying limit it to just column 1. This is column 0 and this is column 1. So on the row side, we're saying all the rows, but on the column side, we're saying limit it to just column 1. So that's why we have this highlighted, which is 2, 6, 10, 14. If we want to select all the rows and all the columns, we'll simply say colon, comma, colon. It means all the rows, all the columns. But we're saying all the rows for only column 1. Good. So this next matrix, it says on the row side 2 colon, and on the row side, that's rows and the column, on the column side it says 2 colon. I'll explain. On the row side, 2, meaning starts from 2, index 2, and give me every other item. So on the row side, let's count. Index 0, index 1, and index 2. So it says give me everything from index 2. Everything. But on the column side, we're saying 2 column. This is column 0, column 1, 0, 1, column 2. And we're saying give me column 2 and count down. So everything from column 2. So from column 2 and every other row, every other columns. So now this is column 0, column 1, and column 2. And interestingly, the other column after column 2 is column 3. So meaning row 2 and every other. So 0, 1, 2 and every other for a column 2 and every other. So this net, and by the time you now use the column to slice it, it now kicks out this 9, 10, 13, 14, and you are having just 11, 12, 15, 16. Okay, so for this last matrix, discard this. You will never have to use this on Autogon AI. But yes, you always find yourself playing around each of these 3 sections. And so let's quickly look at this slicing notation. Now, this is a 1D array. This are 2D arrays. Yes, 2 dimension, 1D, 1 dimension. Now, this is another 1D and 1D. So take out just this particular item here. This is a 1D. Take out just this particular item here. This is a 1D. So this is a 1D, FUDGE. And this is column 0, column 1, column 2, column 3, and column 4. And if you ask 0, column 2, don't forget the upper bound 2 is going to be kicked out. So you'll be having 0, 1, FU. If you are giving 2, column 5, don't forget the upper bound 5 is going to be kicked out. So it's going to be 2 to 4. So meaning 0, 1, 2, 3, 4. That's DGE. If you are giving column 4, don't forget column 4 meaning everything till 4. So meaning 0, 1, 2, 3, 4. Or the 4, can see the 4, the upper bound is dislodged. So you have FUDG, upper bound kicked out. And when you're giving colon, it means everything. And when you're giving colon 1, colon minus 1, it means from 0, 1, everything from 1 to minus 1. And don't forget that minus 1 is always the last item. So if you have 1, from this 1 to minus 1, minus 1 being the last item. But don't forget the upper bound of this is going to be kicked out. And that's why you're having UDG. Great. So to study more on slicing, yes, this is a link that's going to help you more with your slicing knowledge. Beautiful. Okay, so I'll take you back to studio environment. And every single place we used boundaries, we can do the alternative by using slicing. So now if you look at missing data, well, it's not compulsory that you must use slicing for everything. There's sometimes you just want to pick column, just one column, or you want to pick column 22, 23, 24, 22, 23, 24, or column 1, column 8. So it's not compulsory you use slicing. So slicing in that case is going to be very hard. As if I say pick handle missing value here and missing value here, just use their indexes 0 and 1, 2, 3, 0, 3, 0, 3, as simple as that. But for missing data, yes, yes, wanting to handle, you can turn this to slice. but it's harder going through the slice manner. To turn this to slice, you can simply type, so this is 0, this is 1, so you can do 1 colon, in which you don't even need to do it, 1 colon, colon, comma, minus 1. So it's going to bring you out these two, but that's just a harder route. Just bring out index 1 and index 2, except you're having to do much more than 2. Now, if you now look at feature sampling, now this is a common place where you always need to use slicing, and the standard practice is to the standard practice, so it depends on the number of columns that you have. So standard practice, instead of me saying 0, 1, 2, I'll just put colon, comma, colon, minus 1. What this means, it means the first column means what? Rows, everything on the rows, and the second column means column minus 1. It means everything from the rows and everything for the column except the last column. So the minus 1 dislodges the last guy. So everything for the rows, everything for the column, everything for the rows, everything along the column, dislodge the last guy. As simple as that. And on the Y boundaries, we just say colon, comma, minus 1. It means everything on the rows for the last column. I'll take it again. The X boundaries, we're saying colon, comma, colon, minus 1. The first column happens to be the rows, say everything on the rows. And the second column says everything on the column, except there's a limit, a minus 1. So because I've told you that the upper bound is going to be dislodged, so yeah, you are dislodging the upper bound here, because this is a range on its own. Yes, colon, minus 1. So when you are bringing in a range, the upper bound will be dislodged. Now, for the Y boundaries, the row, everything on the row, and the column is saying for just, this is not a range, for just the last column. So if you look at the data set and you say everything, that's for the independent variable, it says colon, comma, colon, minus 1. Colon means everything on the rows, everything. Then column minus 1, it means all the columns except this last guy here, which is purchased. So typing that is going to separate all of the independent variable by removing this dependent variable. Then the Y now says everything, from that same data set. The Y says every single thing on the rows for just the last column. So if you click on this on feature sampling and you run this, you will get the same value. And this is more of an appropriate way to separate your X boundaries from your Y boundaries, especially when you have multiple columns. Yes, for a large data set. So you have, imagine having a data set that the columns are up to 52, 53. Would you begin to pick 0, 1, 2, 3, 4 with just using slicing and saying down to whatever is the last is always the minus 1, whatever is the end is always the minus 1, whatever is the first is always 0. And using this boundary whole thing, you can slice the 2D matrix. Okay, so data encoding is just index expecting, not a slice. Then feature scaling, yes, sometimes you might need to specify slice here. Okay, so I've showed you stuff around slicing, and the last thing I'm going to show you is using Autogon Auto Data Preprocessing. So Autogon has an auto data preprocessing. Good. So this auto data preprocessing does multiple steps. So what we'll just do here is we'll leave, this is the manual route. We've done the manual route. So we connect this guy to the automated route. Great. And for slicing, we'll specify colon, comma, colon -1. And for the dependent variable, colon, comma, -1. If you got it, great. And then we specify mean, the test size 0.1, 0.2, yes. Data encoding, no, we don't need data encoding. One hot encoding threshold. So each of the thresholds, like we can leave these thresholds to their default. Colons we want to exclude, we'll leave this one default, and we'll just call this ADP underscore width. So yes. So there are times you need to enter some of these parameters. So we run the automated data preprocessing, and in a few minutes we are going to see the results. Brilliant. So if we open, you can see the data set was separated into X value, Y value, was even separated into X train, Y train, X test, Y test. All of these steps we've done from missing data down to feature scaling, down to data splitting. So if I open the X value, you can see it's, so now notice something that had happened here. It's encoded the age and also encoded the salary. So it's because this data set is actually small, and it's treating each of these guys as columns. So to avoid this, we need to tune these two columns and avoid it from being encoded. So so if you look at data sets, so age and salary, that's 0, 1, 2. So column 1 and column 2. Yes. So let's go to exclude columns from encoding 1, 2, and yes, we'll run this. We'll run this again. Beautiful. And if we open the X values, what did you notice? So we have France, Germany, Spain. So this has been 100 encoded, and these columns were not touched. Beautiful. So the only thing that is left is to bring in, after the Autogon automated data preprocessing, is to bring in your feature scaling. So if you bring in and connect your feature scaling, and you specify X string and you specify the X test, we bring in our min max scaler. I will call this ADP underscore feature scaling. So for boundaries, now come take a look at this. So for boundaries, we'll be taking in 0, 1, because those are the two items we're wanting to scale. So this is 0, 1. And when we run this, then we are good. So Autogon automated data processing takes in this step, this step, this step, this step. It combines 4 steps and more into one step. And so if you see our X value, our X string, exactly. So you can see it has been scaled. Yes. And then if you look at our X test, it has been scaled also. Beautiful. So directly now from here we can connect it to the random forest classification or any other classification algorithm that is of our choice. Okay. So looking at the slide, so I'd taking a couple of screenshots, so you can play with. So it's either you can use the screenshots to warm up your skills again, and data encoding, handling missing data, feature sampling. We've covered all of this thing. Feature selection, train test splits, done all of this, and automated data processing. We've handled this. Feature scaling, good. Dataset information. Okay, we need to cover dataset information. Dataset information. Okay. So for dataset information, there's a block. For dataset information, there's a block you need to call, and there are a couple of blocks you need to call. So all of those ones are just informational. So if you click on datasets preprocessing, you can drag in the datasets information block. So there are some other blocks again you can drag. You can drag. You can drag show duplicates, and these are some functions you can run on the main dataset, and you can even drag dataset analyze. Yes. So if you connect dataset information and run this, so all of these ones are informational. All of these blocks are informational for you to understand more about your datasets. We can also connect show duplicate. So show duplicate is going to bring out all the duplicates. Yes, all the duplicates. You can specify the columns. So let's have this guy run fully, and then dataset analyze. So myself, I just like to go between dataset information and dataset analyze, and yes, and I can see every single thing, key high-level items about my dataset. So let's give this some seconds to run. And we'll be able to view. Oh, the output is out already. It's because I was still doing some changes. And if you look at this dataset information, we can already see that the country, you can see 10 non-null and 9 non-null. So this is already showing you that there is one that is null. So we can see 10 entries, range index 10 entries, 10 non-null for the country, 9 non-null, 9 non-null, and 10 non-null. So this is telling you already that one is missing from age and one is missing from salary. And also this is also showing you the data type. This is an object data type, this is a float, and this is an object data type. Yes. So if you click on dataset analyze, this also shows you some high-level details about your dataset also. Let's give this some seconds to run. Okay. Okay, so the dataset analysis is done running. If we click on the output, and we can see important data variable categorical, numeric, boolean, number of missing values 1 1, and this is the mean, and this is the standard deviation, and this is just beautiful. Okay, so these functions, especially dataset info and dataset analyze, gives you high level details about your datasets. So the next item we're going to be looking at is drop column. Before we begin to look at datasets, visualize, and ask your data to. So drop column. Yes. So peradventure, there's need to drop a particular column. All you need to do is to drag the drop column. So if we connect the drop column to the data set, that's the data input. If we can tell it to drop, so if you look at the data input, you can see this is country. So peradventure, I don't need country. I can just say on data set drop column 0. And if I want to drop on the X boundary, I can give it something that has X boundary. Don't forget, data set does not have X boundary and Y boundary. So if you pass drop column to data set and specify it on X boundary, it's going to try an error. But because we're connecting the drop column to data sets, that's the data input, it has the data set variable. So we're trying to drop column at index 0. So if we run this, give this some seconds, we'll see the output of drop column shortly. So I have a little slow network, and so if you click on drop column, beautiful, you can see the country column is out. Beautiful. Okay, so one more item we need to look into, and that's heat map. And yes, so before we go into generation of that's visualization, we're going to play with the Autogon Ask Your Data too. So when you have interesting data set like this, you can interact with your data set. So you can do so from this region. So I can click on Ask Your Data Set here, and I can copy some prompt here, and I can type my prompts myself. If I say, what can you see? We'll give this some seconds to run. When it's done running, plots me a data set. So these are some popular prompts I get to use. You can even engineer your own prompts. So good, it has said what it can see. So if I say plot a graph for me, plot a graph from this data set for me. When it's done with that, show me all null rows. So let's give it some seconds. It's going to plot a graph. You can even ask, is this data set balanced? So those are different prompts you can use. So you can see beautiful. So it has plotted age versus salary. And we can see there's a linear relationship between age and salary. You can go ahead and save this. And yes, but we're not saving this now. Yes, and you can always copy the link. Let's open this back. So we can still say, show me all null rows. So you can even come pick up these, some more prompts, all null rows. And you can see Spain had a null row, Germany had a null row. So you can see, show me which country has the highest age. So you can interact with your data sets. You can see Germany has the highest age. Okay, so we can go ahead to ask our data sets more questions. You can play with every single item here, and you can get more creative using different prompts to play with your data sets on using the Autogon Ask Your Data tool. Very powerful tool. Okay, so the last thing I'm going to show us for section 3 is going to be generating test datasets. Yes, so you can generate test one-dimensional or two-dimensional datasets on Autogon AI. What you simply need to do is so you can do this from the quick predict. If you've watched section 1, when I was generating datasets from section 1, I generated prediction data. Yes, using Autogon quick predict. You can also do the same thing here. And the function to do that is scalar to end the array, and good. Scalar to end the array. So all you need to do is select one dimension, and I can generate. I can say 20, 23, 40, 5,000. And if I go ahead to run this, and yes, so scalar to end the array, you don't need to connect it to any data input. For every other guy, you need to connect it to a data input. So I'll go ahead to run this, and you see I already have my response here: 23, 40, and 5,000. And I can go ahead to copy this and use it to inference my model at every point in time. Yes, and so this is the final feature we're showing you, and on Autogon AI Studio, generating synthetic datasets. So it's a very important feature, and to do this on Autogon, you need to go to the dataset section and click on generate dataset, and I can say give me a dataset for employee attrition. So if I say for 50 rows and I generate datasets, we'll give this some seconds to generate. Beautiful. So we can see the employee name, the employee's job, the company, date of birth, and attrition. Yes or no? Beautiful. And you can copy this directly, or you go ahead and save it. And we can see 50 rows, 10, 10, 10, 10, all together making 50 rows. And you can generate data sets for different sectors. Just that easy. And the last item I'm going to be showing us for section 3 happens to be data augmentation. And data augmentation, what we simply do here, so data augmentation is a technique used in machine learning, even in deep learning, to increase and diversify data by creating modified copies or synthetic data sets. So it enhances training data sets, helping prevent overfitting and improve model generalization. Now, if you look at the image to the right, this is a butterfly, and in the process of augmenting this particular image of the butterfly, this is the original this is the detexturized, decolorized, edge enhanced, silent edge map, flip, rotate, and so these are various augmented images from the original image. And yes, this is actually very beautiful. You can have a data set, an image data set of 200 text X-ray image, and then by the time you augment it, you can augment it by generating 5 augmented version of each image, and you have 5 times 200, making it 1,000 images. And then your model can understand better, not just when it sees it in a colored version, it can see it in a decolored version or detectorized version, and to know this is a butterfly. Enhanced edge, it knows this is a butterfly. So coming up with different variations. So when we get to Autogon Libracraft, I'm going to show you how to do this in a very beautiful manner. So I think that is the end of this session. Thank you, and we'll see at the next session.